Hello and welcome. Today we're going to look at logic gates. Firstly, the objectives of this lesson. Explain and use the terms analog and digital in terms of continuous variation in high and low states. Describe the action of a NOT, an AND, a NAND, and a NOR gate. Design and understand simple digital circuits combining several logic gates, and use truth tables to describe the actions of individual gates and simple combination of gates. Now, there's a few new words here that you're going to learn, so we're just going to quickly look at some and recall the use of symbols for logic gates. There's a few new words here that we just want to quickly look at. So the first word is signal, okay, and the root of signal is a sign or an indication. Sensor, the root of sensor comes from sense, that means to feel or to perceive. Processor comes from the word process, which means journey, and in this case it's going to processor is going to be something that makes a decision on the journey. Analog, here the root meaning is according to due proportion, but we're going to look at analog a bit more soon. Digital means comes from digit, the Greek word which means finger or toe, and that pertains to numbers below 10. Okay, so we're going to look at digital in more detail as well. And then logic, the root word pertaining to speaking or reasoning, and we're going to look at logic here as reasoning or making a decision. So first and foremost, we're going to look at an electronic system. So if we think about it, your body has a system as well. You have an input sensor or multiple input sensors. Then you have what we call a processor. See? Okay. And then you have a output. Sorry, processor is one C and double S. Okay, so you've got input, processor, output. In your body, your input can be your eyes. Okay, let's say I throw this pen towards you. Your brain makes the decision, and then the output would be you catching, so your hands moving or your body moving away from, but you have an input sensor which can be your 5 senses. Your brain makes a decision and then it sends a message to how your hand also must respond. Now electronics works in a similar way. We might have a temperature sensor that measures the temperature. When the temperature is too hot, let's speak about a fridge, we want our fridge to stay at below 10 degrees Celsius. So inside my fridge there is a temperature sensor, okay, and if the temperature rises above 10 degrees Celsius, you open your fridge up and you open and close your fridge too much or something like that, then there is a brain or a processor that decides to whether to switch on or off my my fridge unit. Okay, the power to cool down. So there's a sensor, there's the brain part, and there's the fridge. So today we're going to look at logic gates, and we use them as processors. We'll look at another video at the input and output devices specifically. Now before we move on, we need to first discuss this thing called analog and digital. So when I show you guys this picture, a lot of you guys get excited looking at the speed that the car is driving. Now guys, this is an analog meter or a device that measures. It's got a needle and it goes up and down. Okay, that needle can vary, and at the end of the day, the result of something like this can be drawn on a graph similar to the following. So here we see a voltage time graph, and we see that the voltage can have many possible values. So if we look at it, we see that the voltage changes from one value to another. This can be 5, 10, 12. There's negative values, and over time the voltage can have many possible values, just like when you go to your car speedometer, you can have many different speeds at which you're driving. So an analog can have many different values for the speed or for the voltage or so forth. Now your typical digital graph will only look like this. It will only be on or only be off. Okay, so the on value can be any value, the off value will always be 0. So on in this case is 5 volts, off is 0 volts. Okay, so in the computers we know that computers work with ones and zeros, and in the Matrix, the movie The Matrix, those of you who've seen it, basically they portray how computers use these ones and zeros to make information, even visualize things. Okay, but basically the ones and the zeros represent on and off, and combination of these numbers can be used to form anything else, and we use that in what we call binary. So if you take ICT, you would know a bit more about binary, or if you do A-level physics next year, or in A-level physics, you'll learn about binary and how to convert digital to binary. Okay, so now we're going to look at logic gates. By now, hopefully you have played the game that I have suggested for you. So most of what I'm going to show you now is not going to be completely new. Okay, so the first gate that we're going to look at is called the NOT gate. Okay, the NOT gate just has a single input. Okay, it looks like this, and a single output, and all it inverts. Okay, we can call it the teenager, or in my case the 2-year-old in your house, that when you say yes, it says no. When you say do something, it says don't do it. Okay, everything that you say, it makes it the opposite. So if it's on, it turns it off. If it's off, it turns it on. If it's a 1, the opposite of 1 is a 0, and the opposite of a 0 is a 1. So if you have an off signal, it turns it on, and if you have a on signal, it turns it off. Okay, off and on both starts with O's, but this is not an O, it's a 0. So just don't be confused with O. Don't try and make a 0 stands for off, because on also has a 0, O. Okay, so that's the first type of gate. The second type of gate looks like this. The very important one, it's got like a little round one, and we call it a AND gate. Okay, and this is very similar to a cell phone. Okay, in my cell phone, if I want to take a screenshot, I have to hold 2 buttons. Okay, I have to hold the power button and the volume down button. If I do that, it takes a screenshot. Okay, so how I teach students usually is to remember that this is like a screenshot. Okay, you have to have 2 things. Okay, in my case, it's the power and the volume down button. That takes a screenshot. So what's going to happen is, if I only press the volume or the power, and that's, let's say, screenshot. If I only press the volume, but I don't press the power, I'm not going to have a screenshot. Well, let's start by pressing nothing. If I don't press any of them, I'm not going to get a screenshot. When I press the volume but not the power button, I'm not going to get a screenshot. When I press the power button but not the volume button, I'm not going to get a screenshot. But the moment I press both, That is the only time I'll have a screenshot. Now what we see here is a truth table. Okay, so we can make this input 1, input 2, and this is the output. Okay, and so the AND gate's truth table means that, or helps us to remember that the only time it is on when there is an output is when both inputs are on. Okay, so when we have a 0 and a 0, we're going to get a 0. When we have a 1 and a 0, either one of these two, we're going to get a 0. But if both is 1s, we're going to get a 1. What does 1 mean? On. So we're going to get a on. So in real life, what do we want? Okay, easiest situation is to think of a screenshot. Some gas stoves has a knob. You have to press and turn the knob before you can get the gas on. That's obviously not digital, but that's a similar concept. There's a safety mechanism in medicine where you have to press and turn the lid for the medicine. Obviously not digital, but it's the same principle. You have to do two actions simultaneously to open it up. And that's how an AND gate works. The next type of gate that we'll be looking at is the OR gate. Okay, so it looks like a little shield on the side. Okay, and this is called the OR gate. Okay, and the OR gate works very similar to what we have in a car. These lights in the roof, I think I don't know what you call it, but those interior lights in the car, and it opens up when you open up a car door. So the moment I have, let's imagine I've got a two-door car. So there's door 1, there's door 2, and there's the interior light. Okay, so if I open up the driver door, the light goes on, the other door is closed. Okay, wait. If I have no lights, no doors open, the interior light is off. If I open the driver door, the light goes on. If I open the passenger door, the light goes on. If I open both doors, the light goes on. Okay, so the OR gate means either one or both will give me a output. This is the truth table for an OR gate. So if I have 1 and 0, it's going to be on. If I have 0 and 0, it's going to be off. And if I have 1 and 1, it's going to be on. Okay, so those are the three basic gates. Now we get the NOR gate, okay, which is exactly the opposite. So the NOR gate is just going to be 1, 0, 0, 0, which is a broken car door. And then with your AND, you get a NAND, which is the opposite. And to make a NOR, I can also use a OR. The NOR has a little round thing there, but effectively I can also just put a NOT gate in front of the OR, and that whole thing becomes effectively a NOR gate. It inverts whatever the OR says, or the NOR gate, the one like that, has a inversion of the OR gate. Okay, so the NOR and the AND you don't have to remember. You just remember the NOR and the NAND. The AND gate is the screenshot on your phone. The OR gate is the car interior light. And if you remember those two examples and you flip their truth tables around, you get the NOR and the NAND. So now we're going to look at how we use these gates and use combinations of them in real life. So here's the first example where we have a safety system for a controlling motor, where you have to press two switches at the same time for the AND gate to switch on the motor. This is like huge saws or big motors or big machinery that's very dangerous if you accidentally switch it on. Therefore, they've got two switches. Okay, here we have a heater control system, and this heater control system specifically wants to switch on the heater when it's cold during the day. So when it's light, the light sensor picks up light, and when there's light, it gives us an on signal. So in the dark, it will give us an off signal, but in the day, it will give us an on signal. But it must have a temperature switch as well. So when it's hot, the switch is on, but when it's cold, the switch is off. But we want to use the AND gate when it's cold and light. So because the temperature sensor works opposite to what we want, we put a NOT gate in there. So cold is off, but the NOT gate turns it on. If it was warm, it would be on, and the NOT gate would turn it off. And then we receive two signals at the AND gate, both light and cold, and that turns on the heater control. The next one that we're going to see here is a system for lights on the road. So your street lights work in a way that when there's light, we want this street lights off, or when they do maintenance, which they usually do during the day, you want another way to switch it on and off to test the lamp. So we've got a switch. The switch can be on or off. Usually it's off, but then we have a light sensor. When it's light, it gives us a 1. When it's dark, it gives us a 0. But we want it to switch on when it's dark, so therefore we put a NOT gate. The NOT gate switches the darkness to on, and the OR gate now works either during the day or at night. When you use the switch during the day or at night, it automatically switches on because it can be either day or night. So here's a few that you can try and figure out yourself. The first one is allowing a doorbell to work only during the day. So I want you to pause and quickly try that one. So here is my representation. You want to press the button. The moment you press the button on, okay, and there's a light, so the light goes on, both of them will make the doorbell go off. So you don't want the doorbell to go off when nobody's pressing it, and you also don't want, even if someone's pressing your doorbell, you don't want it to ring at night. Okay, so for some other odd reason like a shop or something like that. Okay, when the shop is closed, you don't want the doorbell to ring the whole time. So you've got both of them needs to be on. So when we look at most of these, you can quickly see the word that helps you to decide. So here they give a warning system if the temperature of a domestic hot water system is too high, or when the switch is pressed. So there's an OR gate. Okay, switch in the bathroom heater when cold, and so there's an AND gate. Sound when alarm when it's cold, or so there's an OR gate. So you can just by reading the sentence, okay, see what it's going to be. Give warning if the temperature of the room falls during the day, and also test the switch. Okay, and giving a warning of frosty conditions at night to a gardener who is very tired after a hot day and may want to switch off the alarm. Okay, so if you want to try some of these ones, you can pause the video at each. Okay, there's question 2 to 5 and question 4 to 6. Okay, that you can test and try some of these just to practice a little bit. I hope after this and after playing the game up to level 50, you will now have a good understanding of logic gates.